Okay everyone, this is Chapter 1, Section 1, homework questions on functions. There were quite a few questions, but there was a lot of overlap. So I picked one from each group of questions. I may not answer your exact question, but I probably am going to answer one like it. If you still have a question after you've seen the example, ask me again and we can work through that. So I'm going to start with number 48. And our function, double skin here, our function is q of t equals 2t squared plus 3 over t squared. And we have three different parts. Part A says find q of 2. Now this is just a function notation question. It's basically saying take the 2, whatever you see here, and plug it in for every t. That'll go here and here. So we'll end up with 2 times 2 squared plus 3 on top, and the whole thing is over 2 squared. We do the exponents first, so you have 2 times 4 plus 3 over 4. We do multiplication second. This is order of operations. 2 times 4 is 8. And then you add the top, and that'll be our final answer. So our answer for part A is 11 over 4. Okay. Part B says find q of 0. So this is a very similar question. I'm just putting a 0 in for those two t's. So you have 2 times 0 squared plus 3 over 0 squared. Now for this question, as soon as I see that 0 squared is 0, and you can't have a 0 in the denominator. So this one is undefined. There's no answer for part B. Okay, now part C says let's find q of negative x. So this time I'm going to change each t to negative x. So I have 2 times negative x squared plus 3 all over negative x squared. Now we do the exponents first again. Negative times negative is positive. So negative x squared is actually positive x squared. Negative x times negative x would be positive x squared. And then the same thing on the bottom. That's a positive x squared. So basically drop the parentheses and we're done. My final answer for part C is going to be 2x squared plus 3 over x squared. Okay, that was number 48, and there were a few other questions from that section about function notation, but I don't want to do them all. So like I said, go back if you had a question on 40 or 44 or something from that same section. Now that you've seen this, go back and take a look and see if you can figure it out. Okay. The next one I wanted to do was number 78. And it's a domain question. This comes from the section that says find the domain of, and it gives you a function. And for this one, the function was f of x equals the cube root of t plus 4. Now this is a little bit of a trick question because we're used to seeing square roots and thinking that we have to solve for the domain. We have to figure it out. But that's only even roots, and this is an odd root. There's no problem with taking odd roots. So in fact, the answer to this question, the domain is all real numbers. And I'm going to use that symbol I showed you guys in class, or in the video the other day. A capital R with the double bar on it, that means real numbers. So if you ever want to say the domain is everything, and you want to say all real numbers, but you don't want to write it all out, you can use that notation. So just as a reminder on the domain questions, I said we're only looking for two things right now. Number one, an even root. Not like this. This was an odd root, but an even root. If that was a square root or a fourth root or a sixth root, then we need to make sure that part is not negative. The other thing we're looking for is a denominator, and I didn't have one in this question. That's why the domain's all reals. But we would also have to make sure a denominator never equals 0. So 78 was a little bit of a trick question, but the answer is all real numbers. Okay, I'm going to do one more, do number 84, which is same section, so it's domain again. And this time our function is f of x equals, and it's x plus 2 over the square root of x minus 10. Now this one has both things we just talked about. This one has a square root in it, so that immediately is domain, and I have to make sure that that is never negative. And it also has a denominator, which I got to make sure is never 0. Now the x plus 2 on top actually has nothing to do with this question. You don't even worry about it. It doesn't affect domain at all. The domain comes from the denominator and comes from square roots. So if I do it in two separate steps, I'm going to show you how to do this in 2 steps, and then I'm going to show you how to actually combine it into one. If I do it in 2 steps, I could say, all right, well, let's start with the square root part. If it's a square root, then I take what is inside of it, x minus 10, and I say I need that to be greater than or equal to 0. That comes from right here. Comes from what's inside the square root. Greater than or equal to 0 means not negative. So if I add 10 to both sides, then x has to be greater than or equal to 10. But then I say, well, I gotta make sure that denominator is not 0. So I have a second part where I need to make sure the denominator, and this time I'm including the square root, because we need to make sure that whole denominator never equals 0. Where on my first test, I wasn't talking about the whole denominator, I was talking about the number inside the square root. That's what can't equal, or that's what can't be negative. Now it turns out it doesn't matter, because the first step to solving this would be to square both sides anyways. Cancel out that square root. You have x plus 10 can't be 0. 0 times 0 is still 0. Oh, I'm sorry, it was a minus 10. These are both minuses, not plus. Then what I do is I add 10 to both sides. And basically what you get is x cannot be 10. Now those two groups together are what give you your domain. X has to be greater than or equal to 10, but x cannot be 10. So when I combine those two domains together, my final answer is just x is greater than 10. We know that x has to be greater than or equal to 10, but it can't equal 10, so just drop the or equal to. And that's going to be my final answer, is all real numbers greater than or equal to 10. And I told you you could actually do this in one step. One thing I could have done here, if you go back to the very first thing I wrote, I had x minus 10 is greater than or equal to 0. Well, right off the bat, I could have said, oh, but you know what? That's in the denominator, so it's not just greater than or equal to 0. Let's just make that greater than 0. And then you add 10 to both sides, and you're done with the whole problem in one step. You get x is greater than 10. No matter whether you recognize you can do it in one step or you do the 2 steps separately, either way you're taking both things into account. You're taking the square root and saying that has to be, what's inside it has to be positive or 0. Can't be negative would be a better way to say that. And we're saying the denominator itself cannot equal 0. So this was a great example for domain because it shows both things in the same problem. We had a denominator that can't be 0 and we had a square root that can't be negative. All right, so remember, I didn't do all the questions you guys had. There were a couple other domain questions. There were a couple other function notation questions. If you had a question on a different one, try it now after you've seen a couple more worked out. And if you still have a question about it, email me. I can add to this. All right, have a good day. I'll see you guys soon.